কতক্ষণের রেডি? ওকে, গুড মর্নিং এভরিওয়ান স্টুডেন্টস। প্রিপারেশনস আশা করি ভালো চলছে তোমাদের। আর যারা N25 N23 24 যারা পরীক্ষা দেবে নেক্সট ইয়ার, সো তাদের জন্য প্র্যাকটিক্যালি সেশনটা। বাকিরা যারা এবছর নিট দিচ্ছ, ঠিক আছে, তারা জাস্ট রিভিশনের জন্য একবার থাকো আর ভালো করে প্রিপেয়ার করো, বিকজ এক উইক পর জাস্ট আফটার 7 days তোমাদের নিট এক্সামিনেশন আছে। ওকে, সো আচ্ছা একটু, আচ্ছা ক্লিয়ারলি ভয়েস আসছে, শোনা যাচ্ছে ভয়েস? আচ্ছা, তাহলে শুরু করি, আজকের ক্লাসটা স্টার্ট করি। সো টুডেজ টপিক ইজ বেসিক্যালি very important topic of class 11. Okay, now when you start class 11, so there will be a problem when you go from 10 to 11. So in that transition what happens, you try to keep hold of the class 10 topics, or you can say that sir 11 to bahut tough hai. Okay, then how you will do that? Now in regards to that, what I will say that to the students, that first try to read with some connecting chapters. Now what I mean by connecting chapters, connecting chapters like basic concepts of chemistry is one of the connecting chapter, then few parts of the acid base in the chemical equilibrium, ionic equilibrium, that is a connecting chapter, then beta oxidation and reduction, redox is the connecting chapters. So when we are starting something, okay, starting a session or starting a new academic year, so what you have to do, you have to just start with something which is very basic and very fundamental, and that was exactly our today's topic, is one of the fundamental topic. And last दो lectures जो last दो Sunday हमने lectures दिया है, so that is based on the basic concepts of chemistry. Okay, that is also one of the fundamental topic. Now कैसे कि, so we are today going to talk about another fundamental topic, oxidation reduction. Or every Sunday now onwards, every Sunday there will be the live classes. This is for the live classes for everyone, all the students. Okay, and if you get any doubts, any queries you have, you feel free to write in the comment section. Okay, don't hesitate to write any questions here, okay, because your doubts is what we are going to solve. And every Sunday there is a your doubt clearing session here in our office. It does not matter you are registered or non-registered, feel free to come here and clear your doubts. We are always with you. If you have a great future, if we are able to contribute a single part of your career or your aim, then we will be very grateful, and it will be very nice for all of us to do something good in life. So coming back to our discussion, that is oxidation and reduction, we will try to cover this lecture in two parts. Today we will talk about the basic thing about oxidation reduction reactions, different redox reactions, and different classes of, and there is oxidation state also. From there we will conclude about different states of a metal and how it varies actually. We will talk about that, and in the next lecture, that is on next Sunday, we will talk about another part that I will tell at the end of the lecture. So today's part is very important for the next Sunday's lectures. Okay, actually the two lectures which have comprised today, both are equally important. Okay, so let's start our today's lecture. See, oxidation and reduction, okay, if I say redox, is a very fundamental thing. Now why I'm saying fundamental thing, because there is a proverb which you learned till class 10, is that all reactions are redox reaction. Now बच्चों देखो, redox reactions is okay, chalo, but is it true that all reactions are redox reactions? It's not, right? Maybe, may not be, sir, depends on the example, blah 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 things are there. So let's see what happens. But before that, let me tell you about the fundamental thing about the redox reactions. So this is basically a composed of a reaction. Suppose I have a reaction A to B, any fundamental reaction I have A to B. Now in this case, if this direction, remember, is my oxidation, then beta this direction will be always a reduction. What, why, we will talk in details about that. And what the concept which we are going to put here, that is one of the concept of something called electrode potential. We will also talk about that today. Now, how that electrode potential influences this particular redox reactions and how you can predict also. Beta, that's very important, how you can predict a reaction. Okay, so you know that fundamental of a redox reaction is basically it's an oxidation reaction and a opposite redox reaction, and combining we say, Acha, this is the 1-to-1 species. Suppose if I have another species reaction like this, A plus B is giving my C plus D or any other products. So somehow what I am getting here, that your A, one part of A will be converted into C and the one part of B is converted into D. Now we can say that if one of them is getting oxidized, there are four fundamental points which I will mention in the next couple of minutes, that if one of the species is getting oxidized, then other species will be getting reduced. But what I am trying to say, beta, if this is my oxidation and this is my reduction, this should be my reduction. Okay, Acha, so all of you can hear me. Can you just please comment that all of you are here? Okay, now coming to the part that what is oxidation. Now fundamentally we know that, just I will write few points for your just little bit of brush up, is that number one, oxidation is nothing but your addition of oxygen slash an electronegative atom, addition of oxygen or an electronegative atom. Whereas it can, we can think is that removal of hydrogen, okay beta, removal of hydrogen or slash electropositive atom, okay, removal of hydrogen or electropositive atom. And the last thing, or we know that oxidation is nothing but your removal of electron. Now here beta, I am not mentioning that it is something that removal of electrons from where. But if it is it can form a cation, it may not form a cation. Like if I talk about this reaction, that beta I minus to I2. Okay, here also beta it is going from minus to 0. That means it is basically transferring 2 electrons. Now it is going from a negative charge to a neutral state. It is going a negative charge to a neutral state, right? So definitely that is not forming a cation. So we cannot say. But simply in this process there is a removal of electron. That is why we can say beta this is your oxidation process. Acha. Now similarly if I talk about reduction also, points यहाँ पे mention कर देता है, it will be similarly if addition of oxygen is oxidation, then beta addition of hydrogen, okay, addition of hydrogen or addition of or electropositive atom, addition of hydrogen or electropositive atom, or we can say that it is removal of hydrogen, sorry, removal of oxygen slash electronegative atom. Or the last point what we can say, that will be addition of electrons. Okay, fine. So basically this is the thing, the fundamental idea. Now if I take an example, बहुत ही जो simple examples होता है. Okay, so we are going from, let's say, SN 2 plus, it is going from SN 4 plus. That means while going from 2 to 4, the charge of the increases. That means it is releasing your 2 electron. Whereas if I talk about the reduction process, the Cl2 will be taking 2 electrons and it will be converting into 2 Cl minus. Okay, so this is basically a reduction process where the electron is taken. Achha. Now see one thing, so this is your oxidation and reduction, the fundamental idea. Now beta, this suddenly from where we are getting this thing? What are these things? Suddenly, what are these things? Now coming to the discussion is that these things are called oxidation number or oxidation states. Like if I discuss in this way, देखो बेटा, it is basically nothing but a number. It is basically nothing but a number. Now number means that, let's say if I talk about oxygen, it's a neutral molecule. It's a neutral molecule. Now beta, oxygen being a neutral molecule, the charge over the oxygen is 0. Acha. But if I talk about oxide, O2 minus, oxide, the charge over oxygen is 2 minus. The charge over oxygen is 2 minus. That means your oxidation state of oxide is 2 minus, although there is some variations also there, जो हम बात करेंगे थोड़ी देर बाद, उसके बारे में बात करेंगे. Okay, and the point is that it is basically an imagine, but do you think that only this oxidation state or oxidation number, does it get applied for only charged systems or only cations and anions? No. Simply if I talk about any species which is attached, with any compound, I will come to the example, it will be more clear. Attached to any compound, okay, and it actually depends that what, depends on that metal that what charge it will carry, and it actually depends on what is the environment of the compound. I can give you very simple example. बहुत ही simple example होता है कि suppose you, boy or a girl, you are as a person, definitely the way you behave with your parents, in front of your parents, definitely it's not the same way you usually behave in front of your friends or in school or in front of tuition center, right? You don't, because in different scenarios your behavior is different. Okay, that is what actually make the human species very unique. Okay, now the thing is that if I talk about any species, let's say any metal or non-metal or any chemical substance, any element, chalo, that element, if it is in one, when it is attached in one compound, it will show one oxidation state. But if it is attached in another compound, it will show another oxidation state, but actually depends on that compound, what it actually, that means beta, it depends on the any compound, or I would say environment. It depends on beta environment, that at what environment the element is kept such that it will show that kind of oxidation state. Now you will say, sir, अच्छा, in case of oxidation state, ये जो oxygen के ऊपर जो 2 minus charge है, this is basically its valency. Yes, oxidation state or oxidation number is a valency, there is no doubt in that. But the thing is that if it is a valency or it is something else, but it has some very difference with the valency. बेटा ये boards का बहुत एक important question है. What is the difference between valency and oxidation state? Valency and oxidation number. Okay बेटा, बहुत ही important for your boards. बहुत ही important question for your boards. What is the difference between valency and the oxidation state? अच्छा, now चलो discussion में चलते हैं. Now the question is that how to, this oxidation state you can think of, or oxidation, this species हम देखेंगे कैसे. Likewise, if I talk about that, चलो एक एग्जाम्पल ले लेते हैं. ओके, सिंपल सा एग्जाम्पल ले लेते हैं. लेट्स से H2SO4, एक बहुत ही सिंपल हमारा प्यारा सा सल्फ्यूरिक एसिड है. नाउ व्हाट वी विल डू हियर, नाउ लेट्स से देयर इज अ रूल वे टू डिटरमाइन an oxidation state of any species. Let's say I'm targeting that the sulfur, the oxidation state of sulfur is basically X. चलो बेटा, अगर ये X होता है, and we know that hydrogen is +1 and oxygen is 2 minus. So what we can do beta here? We can do here 2 into 1 plus X plus 4 into 2 माइनस, एंड देखो बेटा सल्फ्यूरिक एसिड is overall the charge is zero, so that will be is equal to 0 because it's a neutral species. Then what we can do, 2 plus x minus 8 is equal to 0, then beta by x is equal to plus 6, x is equal to plus 6. Okay, x is equal to plus 6. That means the oxidation state of sulfur in sulfuric acid is plus 6. अच्छा, सेम वे इफ आई टॉक अबाउट, बेटा ये देखो तो सल्फर डाइऑक्साइड लेते हैं हम, सल्फर डाइऑक्साइड. नाउ इफ यू सी हियर, लेट्स से सल्फर इज x हियर, सो बेटा व्हाट वी कैन राइट, x 2 into -2 plus x, that is equal to 0, so beta x is equal to plus 4. This is what I was talking about here. You can see here two different compounds of the sulfur, जहां पे your in one case your sulfur is having oxidation state of plus 6, whereas in sulfur dioxide the oxidation state of sulfur is plus 4. Got it? So basically depends on the different environments, also different environments the sulfur changes, and it's okay, it's true. Now see, this is so very simple, but what happens when we have different complicated cases? Okay, now in order to tackle those complicated cases, what you basically need, you need to understand that what are the different rules of the determining the oxidation number. तो वही देखते हैं, चलो नेक्स्ट स्लाइड में, that what are the different rules of determining the oxidation state. अच्छा, ओके, अच्छा, जब रूल के बारे में बात करते हैं, देन let's not go by point wise, और बहुत सारे देखना इन बुक देयर इज लॉट ऑफ पॉइंट्स आर रिटन. बेटा इतना घबराने की कोई जरूरत नहीं है. ओके, I will give you here today a very short trick to remember everything. Just what you need to do, you need to remember the periodic table, बस बाकी हम देख लेंगे. So let's draw the periodic table. Okay. Okay. Acha, now let's divide the groups. 13, 14, 15, 16, 17. चलो, so we need group 1, we need 2, we need 13, 14, 15, 16, 17, 18 नहीं चाहिए हमें. अच्छा, फाइन. चलो, now in this case, in case of, remember, देखो ध्यान से देखो बच्चों, in group 1 who we have sodium, lithium, sodium, potassium, rubidium, cesium. बेटा remember, कुछ भी हो जाए their oxidation state will be always +1. +1. lithium, sodium, potassium, rubidium, cesium, francium, कुछ भी हो जाए their oxidation state will be always +1. What about this one? They will be always +2. Group 2 will be always 2+. Okay. Now beta, in this case where you have D block elements or the metals, I would say, चलो D blocks नहीं लिखेंगे, यहाँ पे लिखते हैं metals. चलो metals, heavy metals. In this case we have variation of oxidation state. We have variation of oxidation state. And जो questions आते हैं यही variation से you basically determine. यही वेरिएशन से यू बेसिकली डिटरमाइन. अच्छा चलो यहां पे आते हैं. इन +13, रिमेंबर बेटा ये जो ग्रुप 13 है ना, ये बेसिकली एक बाउंड्री है ना. एक चीज हमेशा ध्यान में रखना, द इलेक्ट्रोपॉजिटिव कैरेक्टर एक्चुअली स्टार्ट्स फ्रॉम हियर. ओके, थोड़ा सा टच रहता है यहाँ पे. सो द जनरल स्टेट विल बी बेटा यहाँ पे क्या होगा मेरा +3 होगा, +3 हो सकता है, +3 +5 और कुछ भी डॉट 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 इट विल बी, बट जनरली +3। ग्रुप 14 +4 होगा या -4, ओके, ग्रुप 4 +4 होगा या -4। ग्रुप 15 बेटा -3, ओके, -3, देन हो सकता है बेटा +5 हो सकता है, ओके, -3 +5। अच्छा, ग्रुप 16 -2 -4 -6, अच्छा यहाँ पे +3 भी हो सकता है, +3 भी हो सकता है, बट एक्चुअली देयर आर सेवरल केसेस वेयर यू हैव टू डिटरमाइन। एंड 17 -1, यहाँ पे होगा -1 हो सकता है। अच्छा, देन योर +3 +5 +3 +5 +7, यहाँ की +1 भी हो सकता है। एक्चुअली यहाँ से इफ यू गो फ्रॉम दिस रेंज ना, दे शो different variation of oxidation states. They shows different variation of oxidation states, okay, different, और basically that we have to determine, और वो हम देखेंगे धीरे धीरे, वो करके हम देखेंगे। अच्छा, सो ये है ग्रुप। नाउ these are the standard states, मतलब कोई भी compound में if there is a potassium you will always take +1. In any compound there is an, let's say, boron, you will take +3. If any compound there is a nitrogen, I will take -3, or have to determine that what is the state if there is nitrogen is a central atom. But the thing is that one point you need to remember always, that is about the identifying the central atom, and वही question में आएगा that calculate the oxidation state of the central atom. Now coming to this part, the next case, okay, कुछ और भी rule होता है यहाँ पे, that I will just add here. One thing is that number one, if I talk about hydrogen, okay, so hydrogen can have, एक shortcut trick समझा देता हूँ, if a hydrogen can have +1 oxidation state or H- oxidation state, both cases हो सकता है, now beta, in this case remember always, in this case when it will happen, when it is the hydrogen is attached with, when hydrogen is attached with elements greater than group 13, okay, greater than group 13, मतलब यहाँ पे, मतलब remember always in these cases, यहाँ पे whatever elements there, if hydrogen they are attached with, hydrogen will show +1 oxidation state, okay. Or beta, one thing remember, if they are attached with the elements that is lesser than equal to group 13, that means agar beta they are attached with group 1, group 2 or group 13, then the hydrogen will show -1 oxidation state, okay, -1 oxidation. I am telling again, if hydrogen is attached with any other elements other than group 13, above group 13, 14, 15 or 16, hydrogen will show +1 oxidation state, and if it is attached with any other group elements which is 1, 2 and 13 or any other metals also, it will show -1 oxidation state, okay. ये बहुत ही important point है। अच्छा, then there is another thing, or oxygen, okay, another thing for oxygen. Now oxygen actually shows two oxidation states, okay. One is called oxygen minus and one is called O2 minus. This state is called peroxide state, okay. This state is called peroxide state, जो बहुत ही problems में हम देखेंगे. And how does peroxides looks like? The peroxides looks like this. और यहाँ पे अगर हम इस हाइड्रोजन को यहाँ पे निकाल दे, so basically it will be O minus or beta O minus. This is your peroxide state, and beta in this peroxide state your oxidation states are -1. अच्छा, -1 are in the oxide state. This is called the oxide state, जो mostly होता है oxide states. This is basically your oxide states, okay. अच्छा, सो रिमेंबर वन थिंग, दीज आर द फ्यू थिंग्स यू नीड टू रिमेंबर. अब बेटा देखो कुछ एग्जांपल्स लेते हैं, अच्छे से क्लियर हो जाएगा. सो चलो चल. अच्छा चलो बेटे एक एग्जाम्पल लगाते हैं, एग्जाम्पल्स करते हैं. चलो कुछ एग्जाम्पल्स. ओके अच्छा, पहले आई एम राइटिंग फ्यू कंपाउंड्स. ओके, ऑल ऑफ यू विल राइट इन द चैट सेक्शन दैट व्हाट इज द आंसर. ओके चलो. अच्छा, Na H2PO4. अच्छा, then H2P2O7. अच्छा, K2MnO4, NaBH4. अच्छा, then Mn2O3 और yeah, चलो. Now here चलो, now here beta determine the oxidation state of phosphorus, manganese, boron and another manganese. Yes. Acha. So if I look at here, let's say phosphorus is X. Phosphorus is X. Okay. Now in this case, if I talk that sodium is your +1, hydrogen is +1 and oxygen is 2 minus. Sodium +1, 2 minus. Acha. Tale it will be 1 plus 2 into +1 plus X plus 4 into -2. That's it. Okay, ऐसे करते हैं. Now what is the X value you will get here? See बेटा यहाँ पे होगा मेरा 3, यहाँ पे होगा 3, यहाँ पे होगा -8. ताले 8 मतलब X will be is equal to, this will be equal to 0. ताले बेटा my X will be is equal to होगा 5 plus. Okay, that means your oxidation state of phosphorus is +5. अच्छा, ये वाला देखते हैं यहाँ पे. So let's check, this is again X. ताले बेटा 2 plus 2X plus 7 into -2, this is equal to 0. And if you do the calculation, this is 2, this is your -14. ताले 14 minus 2, 12, X by 2, ताले X will be is equal to +6. 6 plus. Okay, next वाला K2MnO4, 2 plus Mn का let's say X, ताले plus 4 into -2, that will be is equal to 0. Then beta your X will be is equal to, this is your -8, ताले X is equal to 6 plus. Right? Okay. सोडियम बोरोहाइड्राइड. अच्छा, सोडियम बोरोहाइड्राइड स्टूडेंट्स कैलकुलेट करो तो देखिए, जानो कैलकुलेट करो. फॉर सोडियम बोरोहाइड्राइड व्हाट विल बी द ऑक्सीडेशन स्टेट ऑफ बोरॉन? एनीवन? जल्दी. बच्चे ना. ओके चलो, सोडियम बोरोहाइड्राइड. सी sodium is boron is basically X. Now there is a twist here. What I said that in the previous slide, if hydrogen is attached with any element which is group 13 lesser than equal to group 13, then we will consider this one as a +1, sorry, -1, right? So here remember one thing, sodium to +1 plus your boron is X plus here it will be 4 into -1, that will be is equal to 0. তার মানে your X will be is equal to, this is -4, তাহলে X will be is equal to +3. X will be is equal to +3. Okay? Now, সম্ভবত not -3, it will be +3. It is wrong. Okay? It will be +3. Okay? It will be +3. Okay. আচ্ছা, then better try this one, manganese, try করো। manganese টা try করো একবার। আচ্ছা, হ্যালো হ্যালো, হ্যাঁ ঠিক আছে। আচ্ছা দেখো, so basically this is +3. Yes, Shreya, you are correct, it will be +3 because hydrogen is attached with an electropositive element, that is boron. এটা শিখিয়েছি। Now here Mn2O3, if I see here very carefully, তাহলে manganese যদি X হয়, then beta 2X minus 6 I can write 3 into 2, that is equal to 0, তাহলে beta X is equal to beta your +3. X is equal to beta is your +3. Okay, so these are the few examples or your this how to determine the oxidation state, and practice karna hoga. You have to practice so in order to get it. Next, what is the abnormal oxidation state? Now there are few cases, like I want to mention here one or two few cases. Like if I talk about, let's say this one, H2, let's say if I want to talk about this one, H2SO5. Now in normal conventional way, if I try to calculate the oxidation state of sulfur, then beta remember 2 plus X minus 5 is equal to 0, তাহলে -5 না, sorry, আচ্ছা, plus 5 into -2 is equal to 0, তাহলে beta my X will be is equal to, remember this is -10, তাহলে X will be is equal to your 8. Now we know that if I talk about the sulfur, your sulfur is basically ... sulfur is equal to basically ... 3s2 3p4, correct? That means in its valence shell it has 6 electrons. So if sulfur loses all the electrons also, it can get maximum 6+ oxidation state. That means beta +8 is not possible. That means यहाँ पे some problem is going on. In order to understand this, what we need to do, we need to write the structure of them. Now what is the structure of the sulfur? This one, if I look at sulfur, anyway मुझे 6+ लाना ही होगा. Okay, 6 oxidation, 6. Then it will be like this way. Then H2SO5. So what I will write here? So I will write here one OH here. Okay, and beta यहाँ पे एक double bonded O, then oxygen, hydrogen. तब मैंने यहाँ पे देखो बेटा एक चीज, one thing is that there is a peroxy linkage here. There is a peroxy linkage here, right? Now this peroxy linkage since we have, so our oxidation states definitely will change. That means यहाँ पे हम -2 सबका नहीं ले सकते. We have to take the selective +-1 also. मतलब देखो, the trick I am telling you here, देखो oxygen double bond attached, ताले 2-, oxygen 2 double bond at 2-, peroxy linkage ताले -1, and there is one oxygen -1. So -1, -2 माने sulfur will be your +6 oxidation state. Clear? Okay. Now एक और एग्जाम्पल देखते हैं यहाँ पे, चलो, that is your, this is very important here, बहुत बार क्वेश्चन में आ चुका है नीट में, that is CrO5. If I calculate it by in a conventional way, yes, or Chishman, correct. CrO5, if I calculate in a very conventional way, then what we will get? Let's say अगर X मानो, then beta your X value will be your +10. देखो X value will be plus 10, which is not possible. क्योंकि because we know chromium is basically dot 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 4s1 3d5, right? तो this is my electronic configuration for the sodium, your chromium. So अगर हम यहाँ पे देखें ये जो chromium का जो oxidation state है, if it loses all the electrons, it can get maximum to your +6 oxidation state. If it loses all the electrons, then beta 5 plus 1 6, it can get till maximum 6 plus oxidation state, which is normally feasible, but beta 10 plus is not possible. You need to understand that why it is not possible. Suddenly हमारे काছে yellow and हमने लिख दिया, that is not good, right? You have to understand that why it is not possible due to this reason. Okay, ताले definitely there is some structure is there, some problem is there. That means जब अगर कोई ये वाला कोई दिक्कत आ जाए, कि remember always it is a trick to think about that. अगर oxygen, if you think that there is an oxygen is there or abnormal oxidation states are there, then what you will do? You will take the definitely help of peroxy. Now chromium को हम क्या कर देंगे? First we give this 6 valency. अब 6 valency मतलब बाकी oxygen को यहाँ पे डाल देते हैं and we will just do. So this is your structure of CrO5, okay, and this is basically it's a called butterfly structure. It is called butterfly structure. बहुत ही इंपॉर्टेंट एक स्ट्रक्चर है, दैट इज कॉल्ड बटरफ्लाई स्ट्रक्चर. ओके, अच्छा चलो नाउ एक और देखते हैं हम, एक और एग्जांपल वो बहुत ही इंपॉर्टेंट है, दैट इज वन ऑफ द कॉल्ड द एबनॉर्मल ऑक्सीडेशन नंबर. अच्छा बेटा, अगर हम इसका ऑक्सीडेशन स्टेट कैलकुलेट करें, लेट्स से Br3O8. Okay, so what will be the oxidation state of bromium? एक बार करो, कैलकुलेट करो बच्चों, करो एक बार. What is the oxidation state of the bromium? Done? अच्छा देखो, for bromine, if I look at but a conventional way, if I calculate, then beta it will be 3x minus 16 is equal to 0. তার মানে x will be is equal to 16 by 3. अच्छा, it is a fractional oxidation state suddenly we are getting, তাই না? Suddenly we are getting fractional. अच्छा sir, oxidation state is basically determined by the your changing the electrons. How electrons can be fractional, ताई ना? That is the biggest problem or biggest question you can ask yourself. अच्छा, तो basically now what actually happens here? Okay, now see, if I want to look at here, I need to look at the structure. Now one thing is always confirmed that bromine cannot go beyond +7. Bromine cannot go beyond +7. So maximum valency of a bromine here will be +7. Maximum it can attain the +7. Why? Because if I talk about bromine, अगर ध्यान से देखें तो डॉट 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 बेटा यहाँ पे होगा, I think bromine is your, अच्छा fluorine is 2, chlorine is 3, bromine is 4. ताले यहाँ पे होगा डॉट 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 4s2 3d10 4p5. Okay, so if we want to release all the valence electron, it can add 5 plus 2, that is +7 oxidation state. It can go max to max. It can go max to max, right? अच्छा, तार माने 7 will be the valences. तो वही idea लग के let's draw the structure. So double bonded O, double bonded O, double bonded O, double bonded O, right? Like this. Acha. Now if I look at here very carefully, this is beta 2 minus, this is beta 2 minus, this is beta 2 minus, this is 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 2 minus. Now with respect to this bromine, the charge distribution will be here 0, so this will be beta your 6 plus. Similarly, this will be beta your 6 plus and this will be beta your 4 plus. That means what we can write here, 6 plus 4 plus 6 divided by 3, that means is equal to your 16 by 3. That means we are correct. That means यहाँ से one thing what we can conclude here, remember, is that the oxidation states which we are reporting, that oxidation state is basically nothing but your एवरेज ऑक्सीडेशन स्टेट. ओके, मतलब ये जो ऑक्सीडेशन स्टेट यहाँ पे हमने लिखा है ना, दिस इज बेसिकली योर एवरेज ऑक्सीडेशन स्टेट, एवरेज ऑक्सीडेशन स्टेट. ओके, और ये वाला भी मतलब ये यहाँ पे जो आ रहा है, यहाँ पे जो आ रहा है, ये प्रीवियस एग्जांपल में भी जो आ रहा है, दिस ऑल आर बेसिकली योर एवरेज ऑक्सीडेशन स्टेट, जो यहाँ पे ड्यू टू दिस इन दिस ब्रोमीन Br3O8 एग्जांपल में एकदम क्लियर हो गया. Okay, and this is something is called your paradox of oxidation number. It is called something called paradox of oxidation number. Okay, मतलब जो दिखता है वो होता नहीं है. We have to go inside or we have to go in the deep down to know the structure. Then you can actually understand that beta what is the actual oxidation state. ओके, चल. नाउ कमिंग टू द नेक्स्ट एप्लीकेशन, चलो एक एमसीक्यू करते हैं. चलो आई एम गिविंग यू 1 मिनट टू सॉल्व. ओके, चलो एक एग्जांपल करते हैं. 1 मिनट टू सॉल्व आई एम गिविंग हियर. बहुत ही सिंपल है. बेसिकली हियर व्हाट यू हैव टू डू, यहाँ पे जो तुम्हारा वेनेडियम है, दिस वेनेडियम यू हैव टू कैलकुलेट द ऑक्सीडेशन स्टेट ऑफ द वेनेडियम. ओके, सिंपल रूल लगाओ, जो रूल पढ़ा है, 1 मिनट टाइम दिया, सॉल्व करो. ओके, चलो एनीवन, इतना टाइम तो नहीं लगना चाहिए, इतना टाइम तो बेटा नहीं लगना चाहिए. वेरी सिंपल. चलो, इतना टाइम तो नहीं लगना चाहिए, बहुत ही सिंपल है. अच्छा अच्छा बेटा, यहाँ पे देखो, सीजियम, सीजियम इज योर 4 into +1, तो सीजियम इज अ ग्रुप 1 एलिमेंट, তাহলে 4 into +1 प्लस सोडियम ग्रुप 1 एलिमेंट, इसका भी होगा +1. आया हाइड्रोजन, हाइड्रोजन का यहाँ पे क्या लेंगे हम, हाइड्रोजन का यहाँ पे ले, सिंस ऑक्सीजन यहाँ पे है, सो हाइड्रोजन का हम लेंगे यहाँ पे +1. चलो वेनेडियम, लेट्स से इट इज x, ताले बेटा ये होगा 10x, ये होगा 10x. अच्छा, देन योर ऑक्सीजन +28 into -2, that is equal to 0. That is equal to 0. ताले बेटा what will be the 4 + 1 + 1 6. ताले बेटा यहाँ पे होगा 6 + 10x - 56 is equal to 0. ताले बेटा remember x will be is equal to 50/10, that is equal to 5+. Okay, so correct answer होगा ऑप्शन नंबर 2, 5+. ओके, चलो नेक्स्ट एक और देखते हैं. व्हाट इज द ऑक्सीडेशन स्टेट ऑफ द मोस्ट इलेक्ट्रोनेगेटिव एलिमेंट्स इन द प्रोडक्ट ऑफ द बेरियम ऑक्साइड विथ डाइल्यूट सल्फ्यूरिक एसिड. अच्छा बेटा रिमेंबर यहाँ पे एक चीज, दैट इज BaO2 प्लस H2SO4. ओके बेटा ये जो रिएक्शन है, दैट रिएक्शन एक्चुअली विल प्रोड्यूस H2O2 प्लस BaSO4, H2O2 प्लस BaSO4. नाउ यहाँ पे if I look at, there are most oxidation states. If I look at the most oxidation states here, that is most electronegative element in the product, that is यहाँ पे the oxygen in this compound and oxygen is this in this compound. Beta, this is a peroxide, correct? This is a peroxide. This is a peroxide. So peroxide मतलब यहाँ पे होगा मेरा क्या, यहाँ पे होगा -1 oxidation state, right? और since is an oxide, we have -2 oxidation state. मतलब जो इलेक्ट्रोनेगेटिव है, एक है -1 और एक -2, और करेक्ट आंसर विल बी ऑप्शन नंबर 2. Clear everyone? I need a yes from everyone. Clear? Okay. अच्छा, this is another variation of a problem is that A, B, C have oxidation numbers +6, -2 and -1. So what will be the possible molecular formula? Okay, now ये जो problem है, it is a very straightforward problem, very straightforward problem. So what you do, you will just remember one thing. Any compound, the idea is that for any compound, remember summation over oxidation states will be always is equal to 0. Summation over oxidation states will be always equal to 0. So আমি এক এক করে নেব, but let's say if I talk about compound 1 which is your A2BC. अच्छा, so if I take the oxidation state here, यहाँ पे बिठाते, then +6 will be here, +12, -2 और C एक है, ताले -1. Definitely this is not equal to 0. Definitely this is not equal to 0. Next example लेते हैं, next वाला, your A B2C2. अगर ये वाला लेते हैं, then क्या होगा? Then बेटा this will be +6, -2, 2 तले -4 and C2 -1 into 2 तले -2 तले basically this is equal to 0. Okay, so हमें आंसर मिल गया, so yes, the correct answer is option number 2, A, B2C2. Idea, remember, the idea is basically your summation over all the oxidation states, in a compound will be is equal to 0. This is the particular idea. Acha. Now let's talk about one application of the oxidation number. Now अच्छा ये वाला ठीक है ना, अच्छा ओ तो यहाँ पे 2 स्लाइड हो गया. अच्छा सी, now see, coming back to this one, one of the application of the oxidation number, that is basically the understanding the reduction potentials. Now let me give you an idea about that, how this reduction potential actually works. Think in this way. Let's say there is a species A that is going to A plus. A species A is going to A plus. Now while going this one, definitely this is an oxidation process. Definitely this is an oxidation process. Now in this oxidation process, what it is doing, it is releasing an electron. During this oxidation process. Now the point is that, let's say there is a wire, that wire connecting A and A plus is a wire. Now in this case, what happens, from A to A plus there will be electron flow because it is releasing the electron, so there will be electron flow. Now the direction of this electron flow, definitely the opposite direction, there will be a current flow. Current means as thought, but a current flow. Now when in a wire connects two ends, and when it actually generates the current, remember one thing beta, there will be a potential generated. There will be a potential generated. Okay, remember one thing, there will be a potential generated, and whatever the process is, maybe it's an oxidation process or it's a reduction process. Remember one thing beta, that potential is called, if the process is an oxidation process, the potential is called oxidation potential, and if the process is a reduction process, then that is called reduction potential, or in other words or small way we can say it's something called redox potential. It is something called redox potential, that is, and there is a series of reduction potential, that is basically E0 red I am talking about here. It's the reduction potential of different species is given. Now you will tell, sir, कि फायदा क्या है हमें जान के, right? It's a valid question, which is that what is the majority use is that why we want to use this reduction potential. Now remember one thing that here, चलो एक चीज यहाँ पे बताऊंगा कि remember one thing here that suppose if I talk about fluorine, okay, if I talk about fluorine, fluorine will have a stronger tendency to accept an electron and go to F minus state, and that is why its reduction potential is very high. Now trick, what is the trick? Remember always, if my E0 reduction is positive, then remember the potential, if the potential is positive, then your reduction process is favorable. That's it, nothing else. Means if I talk in this direction, higher the most positive reduction potential, it will be the most favorable process. It will be the most favorable process. Okay, it will be the most favorable process. And now beta, one thing is clear that if this process is more favorable, that means opposite process is not favorable. Now one thing is here that your E0 red is always is equal to minus of E0 ox. E0 red is always is equal to minus of E0 ox. Means if the reduction potential is plus 2.87 for F to F minus, then the F minus to F2, the oxidation potential will be minus 2.87. Now what does this positive case means? Now positive case means, remember that from, if I say that this is more favorable, that means if I go up to down, reduction will be more favorable, ज़्यादा favorable होगा. अगर बेटा यहाँ पर रिडक्शन ज्यादा फेवरेबल होगा, then ऑक्सीडेशन कम फेवरेबल होगा. अब देखो कोई स्पीसीज, अगर इस स्पीसीज लेट्स सी वी टॉक अबाउट फ्लोरीन, इसको एक इलेक्ट्रॉन चाहिए गेट टू गेट कन्वर्टेड इनटू F माइनस, दैट्स वेरी ऑब्वियस, इसको चाहिए. नाउ डेफिनेटली इन ऑर्डर टू फैसिलिटेट दैट प्रोसेस, डेफिनेटली इट विल टेक एन इलेक्ट्रॉन. अब इलेक्ट्रॉन तो बाजार में तो नहीं मिलता कि जाके खरीद के लेकर आए, राइट? बाजार में नहीं मिलता. सो व्हाट यू हैव टू डू, इट हैज टू टेल another species that beta give me electrons. Okay, so what will happen while doing this process? Let's see, if I talk about hydrogen, hydrogen will lose another electron and that will give to fluorine. Hydrogen will lose another electron and that will give to fluorine, and fluorine will take this electron and it will convert into F minus. Okay, that means here what is happening? Here although the fluorine is getting reduced, the hydrogen is getting oxidized. That means this process, your fluorine is acting as a good oxidizing agent. Fluorine is acting as a oxidizing agent. Now in reversely, can we think in this way that beta dekho, hydrogen is getting converted into H plus. The hydrogen is giving an electron. Hydrogen is giving an electron. Now beta वो electron तो इधर उधर नहीं घूम सकता, right? So fluorine is taking that electron. So in other way, what we can say here that hydrogen is forcing fluorine to take the electron, correct? That means hydrogen here is behaving as a reducing agent. Hydrogen is behaving as a, here remember, reducing agent, right? So basically from this list we can easily predict that if I take any couple, redox couple here, okay, not boyfriend girlfriend couple, redox couple here, which one will behave as an oxidizing agent and which one will behave as a reducing agent. Now remember always one thing, that if my reduction potential is very highly positive, then beta in this direction they have a higher tendency to be a oxidizing agent. higher tendency to be an oxidizing agent. Okay, remember this all, because जो लोग अच्छे reduced होते हैं, that can behave as a good oxidizing agent, और जो लोग अच्छे ऑक्सीडाइज होते हैं वो लोग कैन बिहेव एज अ रिड्यूसिंग एजेंट. एक चीज दिखा देता हूं यहाँ पे. लेट्स से इफ आई टॉक अबाउट हियर, ओके ये लिस्ट ज्यादा आते नहीं है, मतलब इट्स लिटिल निकल. नाउ निकल इज अ मेटल, वी नो राइट, निकल इज अ मेटल. नाउ निकल हैज अ रिडक्शन पोटेंशियल -0.25. दैट मींस इज ऑक्सीडेशन पोटेंशियल इज पॉजिटिव, मतलब निकल का ऑक्सीडेशन ज्यादा फेवरेबल है कंपेयर टू रिडक्शन. करेक्ट. अच्छा, that means in a solution if I put a nickel, then nickel will try to lose an electron. अगर निकल ज्यादा इलेक्ट्रॉन लूज कर, निकल इज लूजिंग एन इलेक्ट्रॉन, तो उसको किसी को तो लेना होगा राइट. सो निकल इज बिहेविंग एज अ रिड्यूसिंग एजेंट राइट. ओके, सो दिस इज द आइडिया अबाउट द redox potential and how you can use this redox potential in order to get that which one कौन सा वाला ऑक्सीडेशन होगा and कौन सा वाला रिड्यूस होगा. You can easily do that. अच्छा, नाउ एक एमसीक्यू करते हैं. चलो एमसीक्यू, दैट सम रिडक्शन पोटेंशियल्स आर गिवन, सो व्हाट इज द ऑक्सीडाइजिंग ऑर्डर ऑफ द ऑक्सीडाइजिंग पावर ऑफ दिस वन. सो आई एम गिविंग यू 1 minute टू सॉल्व. ट्राई करो. चलो 1 minute टू सॉल्व, एक बार ट्राई करो. चलो गिव अ ट्राई. बहुत ही सिंपल क्वेश्चन है. अच्छा, now see, given standard reduction potentials here, one thing, now देखो यहाँ पे your cobalt has the most positive oxidation state. Cobalt has most positive reduction potential, right? Most positive reduction potential. Now beta, most positive reduction potential means it will have a highly, it can behave as a good oxidizing agent, right? So it will behave as a good oxidizing agent. One idea is that higher the reduction potential, good oxidizing agent, right? मतलब सबसे पहले होगा मेरा कोबाल्ट 2+, then Pb2 Pb4+, right? Then cerium 4+, and then bismuth 3+. ताले कौन सा वाला आंसर होगा? ऑप्शन नंबर 4. नो नंबर तो ऑप्शन नंबर 4. और यस, ऑप्शन नंबर 4 will be the correct answer. Okay, option number 4 will be the correct answer. Acha, now this is very important, that is manganese oxidation states. Now I have 2 already video lectures, you can see, check that the different medium, what are the oxidation state of the manganese. So remember always that manganese has total 1 2 3 4 5 6 oxidation state, and all of these oxidation states have different colors. Just I will tell here one thing, that MnO4 minus, that will be changing into next MnO4 2 minus, right? Acha, this is one, can be one case. Then in another case it can go to MnO2, right? And in another case it will go to Mn2+. now beta ये जो तीनों चीज है ना, ये तीनों different cases में होता है, और it can go from here to here also. now यहाँ पे अगर हम देखें different oxidation state, 7+, 6+, 4+, and beta 2+. now other than this there is your 5+ state is there. Okay, there is your 3+ state is there. Acha, this is the color of the 2+, this is your 4+, this is your 6+, and this is your 7+. now other than this, remember one thing always here beta, that is your 4, 6, 7 and 2. अच्छा, not 6. ओके, रिमेंबर वन थिंग दैट ये जो तीनों स्टेट्स है, ये जो तीनों स्टेट्स है, these states are most abundant state. These states are most abundant states जो कि हमें पाया जाता है, जो कि हमें जो हम पाते हैं मोस्ट abundant state of the manganese. और बेटा ये जो स्टेट्स है +5 +6, ओके, और ये जो तीनों स्टेट्स है they are basically very less abundant state. Less abundant state. Okay. Now one thing is you remember always that ये वाला जो state है +6 state of the oxidation state, this one actually disproportionate. हम बात करेंगे अभी disproportionate. Okay, this state actually disproportionates in normal, in medium. Okay, so these are the different oxidation state of manganese. अच्छा बेटा, और एक चीज यहाँ पे बताऊंगा कौन से मीडियम में होता है. This happens in your basic medium, 7 to 6 basic medium, 7 to 4 होता है your in neutral medium, 7 to 4 आता है in your neutral medium, और 7 to +2 होता है in your acidic medium. Always remember this thing. Okay, ऑलवेज रिमेंबर दिस. ये बहुत ही इंपॉर्टेंट कॉन्सेप्ट है, बहुत ही इंपॉर्टेंट कॉन्सेप्ट है. अच्छा, ये वाला प्रॉब्लम करते हैं. व्हाट इज द इक्विवेलेंट वेट ऑफ द KMnO4 इन एसिडिक, न्यूट्रल एंड मीडियम? नाउ व्हाट आई सेड इज दैट इन एसिडिक मीडियम, प्रॉब्लम में अगर देखते हैं, इन एसिडिक मीडियम योर MnO4 माइनस changes to Mn2 plus in your acidic medium. In your basic medium, it will be giving to MnO4 minus to MnO4 2 minus, and in your neutral medium, it will be giving to MnO4 minus Mn2 plus, and it will be MnO2. Now, अगर हम यहाँ पे देखें the oxidation states, this is 7 plus, this is 2 plus, this is 6 plus, this is your 4 plus. The number of electron change here is 5 electron, 7 to 6 1 electron, and 7 to 4 beta 3 electrons. 7 to 4 3 electrons. Then what will be the equivalent weight? In this case, it will be your m by 5. In this case, it will be m by 1. That is equal to m. And this case, this will be is equal to m by 4. Sorry, m by 3. M by 3. So is there any option? M by 5, m by m. अच्छा, acidic, neutral or alkaline. ताले acidic m by 5, neutral m by 3 and m. ताले correct answer will be option number 3. Correct answer will be option number 3. अच्छा, अच्छा, since हम disproportionate reaction के बारे में बात ही कर रहे हैं, then let's talk about that. Now beta, remember one thing is that when we talk about a disproportionation reaction, a disproportionation reaction is a reaction where you have an intermediate oxidation state, and from that intermediate oxidation state, the species will go to two different oxidation states. Okay, like let's see if I talk about this one. Copper plus. Now in aqueous medium, copper plus actually goes to copper 2 plus and goes to copper 0. Now beta, in this case एक चीज देखो ध्यान से, copper plus is going to copper 2 plus. This process is your oxidation. This process is your oxidation. Whereas if I go from copper plus to copper 0, this process is your reduction. This process is your reduction. That means in medium, in solution, one species is getting simultaneously oxidized and simultaneously reduced. These kind of reactions are called your disproportionation reaction. Now beta remember that there are ways to determine or define that what is the disproportionation reaction. चलो एक और एग्जांपल यहाँ पे लेते हैं हम, KClO3, okay, KClO3 that will give me, if I heat, KClO4 plus beta KCl. Okay, now here if I check the oxidation states, in this case oxidation state is how much? Chlorine beta -6 plus 1, তাহলে এটা হবে হচ্ছে +5. In this case you will get 7 plus and you will get -1. Now +5 to 7 plus, definitely loss of 2 electrons, and +5 to 1 minus, there will be gain of 6 electrons. Now this is not a balance. Next Sunday we will talk about that ये जो reactions है ना इलेक्ट्रॉन चेंज यूज करके हाउ टू बैलेंस हिम, हम डिटेल में बात करेंगे नेक्स्ट संडे सेम टाइम पे. Okay, chalo. Now in this case what I can see here is that this is an oxidation process and this is an reduction process. That means here one species is simultaneously getting oxidized and simultaneously it is getting reduced, correct? So basically that's why this is called an disproportionation reaction. बहुत ही simple है, बहुत ही simple है. Okay, but don't worry, it's just you have to identify that there is a species. एक problem बात करेंगे अभी थोड़ी देर में. You have to identify the species and that species what is the oxidation states. देखो बेटा ये जो problems, now remember one thing, कोई reaction को ठीक से लिखो पहले. Okay, अभी since you are starting here you cannot identify that which element we are talking about here. So once you write the overall reaction, वहां पे सभी atoms का oxidation state लिख लो. Now कुछ oxidation state there will be same, but कुछ there will be different. Now जो different है, now check, they are either electron is getting accepted, but it is decreasing the oxidation state, or it is increasing the oxidation state. Check that one. From there you can easily identify that which is oxidation and which is reduction. हम बात करेंगे थोड़ी देर में. Okay, चलो. So ये वाला idea होगा. That means one I can say, ये अपन note देकर लिख लो, simultaneous oxidation and reduction, simultaneous oxidation and reduction of a species. Okay, species. चलो, clear all of you? चलो, next हम problem के बारे में बात करते हैं. Which of the following does not represent a redox reaction? ना यहाँ पे बेटा एक चीज हमें देखना होगा कि does not represent the redox reaction, इसका मतलब क्या है? इसका मतलब है definitely बेटा in a redox reaction there will be, idea is there will be change in oxidation states. Okay, so there will be change in oxidation state in a redox reaction. अच्छा चलो यहाँ पे देखते हैं बेटा, चलो पहला वाला देखते हैं. Cr2O7 2 minus oxidation state of chromium, so 2x minus 14 is equal to 0, तो x equal to -2, ताले बेटा यहाँ पे क्या होगा, x will be is equal to +6. यहाँ पे देखते हैं chromium -8 is equal to 2, तो मैंने यहाँ पे भी होगा +6. बा वो तो ऑप्शन ही होगा लो, तो पहला वाला ऑप्शन ही हो गया. So +6 to +6, so delta electron change is equal to 0. That means this is not a redox reaction. This is not a redox reaction. Not a redox. चलो एक और देखते हैं रैंडमली. ओके बेटा, अच्छा देखो यहाँ पे क्लोरीन क्या है मेरा, कैल्शियम 2+, चलो छोड़ दो, कैल्शियम 2+ छोड़ दो. अच्छा क्लोरीन वाला देखते हैं, क्लोरीन इज 0 हियर. अच्छा यहाँ पे होगा क्लोरीन, यहाँ पे क्लोरीन होगा -1 और यहाँ पे होगा क्लोरीन कितना होगा +2. मैंने x पकड़ लेते हैं अगर, सो 2 + 2x -4 इज इक्वल टू 0, ताले बेटा x will be is equal to -1. x will be is equal to -1. मतलब यहाँ पे होगा क्लोरीन का ना -1 ना, सॉरी क्या होगा +1, सॉरी +1, 4 होगा +1, क्लोरीन +1. So 1 you are getting +1 and beta -1. That means this reaction क्या होगा? This reaction is my disproportionation reaction. Okay? चलो नेक्स्ट प्रॉब्लम देखते हैं. Which is the example of a disproportionation reaction? तो हम क्या देखेंगे यहाँ पे? The variation of the oxidation state. कौन सा वाला यहाँ पे काम कर रहा है? कौन सा वाला ऑप्शन यहाँ पे काम कर रहा है? That is gives you the variation of the oxidation state. अच्छा देखो पहला वाला 7 + 2 2+, डेफिनेटली नॉट अ डिस्प्रोपोर्शनेशन रिएक्शन. ठीक है. अच्छा देन Cl0 to -1, bromine -1 to 0, sodium +1 to +1. फाइन, दिस इज नॉट अ डिस्प्रोपोर्शनेशन रिएक्शन. ये देखते हैं बेटा 7 + to 6 + to 4+. Is it a disproportionation reaction? Definitely not. क्यों बेटा? क्योंकि remember this is going from 7 to 6 and 4. 7 to 6 and 4. So it is going to the down oxidation state, not up. माने remember one thing in disproportionation, whatever the state will be, एक मेरा ऊपर जाएगा और एक मेरा नीचे जाएगा. It will be an intermediate state. Okay, intermediate state. So definitely this is not a disproportionation reaction. चलो लास्ट वाला अगर देखते हैं, so this is my +1, this is my +2, this is my 0. So definitely this is my disproportionation reaction. Yes बेटा, ऑन है correct. ऑन है सुमेधा correct. ऑयन सॉरी ऑयन. ओके चलो एक और लास्ट प्रॉब्लम देखते हैं यहाँ पे. that the equivalent weight of the Na2H2O3 in this reaction is what? Now remember one thing, that your equivalent weight of any redox reaction is basically molecular weight by delta E, माने number of electron change. Number of electron change. तो यहाँ पे मेरा major element क्या होगा? In this case my major element is sulfur. Major element is sulfur. So what I will do? I will check the oxidation state change for the sulfur. चलो बेटा देखते हैं. Your S2O3 it is going to S4O6. Okay. अच्छा देखो तो oxidation state कैलकुलेट करते हैं यहाँ पे. अच्छा S2O6 2- and S4O6 also 2-. अच्छा बेटा यहाँ पे देखते हैं क्या होता है बेटा. 2x - 6 is equal to -2. ताले x will be is equal to 6 - 2 4/2 माने +2. मतलब यहाँ पे सल्फर होगा मेरा +2. ओके यहाँ पे देखते हैं 4x - 12 is equal to -2. ताले 4x is equal to 10. तो बेटा x will be is equal to बेटा 2.5. मतलब यहाँ पे मेरा ऑक्सीडेशन स्टेट होगा 2.5. करिए तो बेटा होगा यहाँ पे 2.5. अच्छा तन्मने यहाँ पे मेरा व्हाट इज द डेल्टा ई. डेल्टा ई इज 2.5 - 2, सॉरी हाँ दैट मीन्स 0.5. so there is number of electron changes half. now this is for 1 electron, this is for 1 electron. so बेटा for 2 electron, sorry for 1 sulfur. now बेटा यहाँ पे दो सल्फर है, सही तो सल्फर दो सल्फर है 2 to 4. so it is by 2. that means यहाँ पे for 2 it will be this one, that is 1 electron. तले 1 electron change. तले the correct answer will be molecular weight by 1, that is equal to molecular weight. Clear all of you? सबको समझ में आया? Can you give a comment बेटा? all of you clear? okay fine then. so this is what today was the topic of our discussion, and next day what we will talk about, next Sunday same time we will talk about that how to balance a redox reactions. okay next day we will talk about how to balance a redox reactions, और उसके साथ we will also talk about that how this, what are the real application of this redox reaction. it means that what exactly this the application of the redox reaction, how it actually the applications, right? so okay, So from my side, bye everyone. Take care, have a good day. Or we are having a biology marathon today from 4 p.m. So don't forget to watch that. Okay, so all of you, from my side, from the team, I am RGD Sir. Take care. Chalo, goodbye. See you next time.